Okay, for this problem, it says sketch the graph of a function that satisfies the given conditions. Now these conditions I broke up a little bit and made it easier for you to be able to see what's going on. So I broke up the f of x conditions, the f prime of x conditions, and f double prime conditions. The first thing we're going to do is establish what f of x, f prime of x, and f double prime of x mean. So f prime of x, when f prime of x is positive, it's going to equal an up arrow, and when it's negative, it will equal a down arrow. When we're given f double prime of x, when it's positive, this will equal u for up, and will equal negative. Negative will equal d for down. Now that we've looked at that, now we're going to draw a circle, and we're going to split up the circle in 4 segments. So if you split up a circle in 4 segments, you get something like this. So at this point, when f of x is positive, or up arrow, and f prime of x is negative, or d for down, we will get this shape for concave down, and f of x is increasing. So we're going to do that for all points. So at this point, we're decreasing, and we're going to get concave up. Here, we're decreasing, and we'll get concave down. And finally here, we'll get increasing and concave up. Now that we looked at that, now we're going to sketch our functions. We're going to put them on a timeline. So we have f of x, f prime of x, and f double prime of x. We're just going to draw a little 3 lines like this, 1 line for each function. So the first thing we see is that when f of 0 is 0, so that means for our f function, at 0 we have a point. So we'll just put a point right there. Now it says that as x approaches infinity, f of x is 0, which means that x is continuous to the right on the graph. It doesn't mean the entire problem is continuous, it just means at this point we are continuous to the right. Here it's showing us an asymptote because the limit of x is approaching 6, f of x is negative infinity. So that says that at both sides of 6 we will be going down on a graph. So let's not worry about that for a second. Let's start looking at our first derivative function. So it says that our first derivative is negative from the points negative infinity to negative 2. So we're going to put a 0 here, and then negative 2 will be about right here. So from negative infinity to negative 2, f prime of x is negative. So we put negative marks here. Then it says it's also negative from 1 to 6. So if we put a 1 here and a 6 right about here, we're negative. So we'll put negative signs in there. Then it says from 9 to infinity, we're also negative. So if we put 9 about here, it says we're negative here. Now it says we're positive from negative 2 to 1. So all throughout here we're positive. And then it says we're positive from 6 to 9. So we're positive here. Now let's look at f double prime of x. It says that we're negative on the second derivative of f of x from the point 0 to 6. So if we put our points in here of what we already established, and then it says from 0 to 6 we're negative, so put in negative signs there. From 6 to 12 we're negative. So if we put 12 about right here, it says we're also negative in here. Then it says we are positive from negative infinity to 0. So we'll put positive all throughout here. And then it says we're also positive from 12 to infinity. So over here, we're still positive. Now, from this, using our 0 point, we can draw our y-axis, and then we can draw our x-axis. So the first thing it gives us is that we know that our line crosses at 0, 0 because when f of 0, x is 0 when f is 0. So we put a point right here. And by this note, we'll know that at some point, our line will cross through this point. And we don't know if it's going to go this way or if it's going to go this way. So what we're going to do is we're going to draw lines at each interval that we've been given, or each point that we've been given on our x-axis. So here, at negative 2, at 1, at 6, at 9, and at 12. And then we can label these. So we're negative 2 here, we're 1 here, we are 6, 9, and 12. Now, looking at what we've sketched previously, we can see, now we can use the little chart we've made here prior. So, as when f of x, or f prime of x is negative, or the down arrow, f double prime of x is positive, or concave up. So we'll look at down here and concave up. Gives us this shape. So now we know from negative infinity to this dotted line, or negative 2, we'll have this shape. And this is going to go the same for the rest of these. So we have positive and positive, so this will give us up and up here. So we'll have this shape. Here we're positive and negative, so we're up and down, which will give us this shape. Here we're down and down, so we'll get this shape here. Here we're positive and negative, so we're up and down, which is again this shape. From 9 to 12, we're negative and negative, which is down and down, which is this shape. And then lastly, from 12 to infinity will be negative and positive, so that is down and up, which is this shape. Oh, I'm sorry, not that shape, which would be this shape here. Okay, excuse me. Okay, now if we look on here, we're going to go back to the asymptotes. So we have an asymptote at 6. So as the limit of x approaches 6, f of x is negative infinity, which means we're going to have something that looks something like this. And then we also know that as x approaches infinity, f of x is 0. So we're going to have something like this or like that. Now from looking from this line, it's only plausible to have x approaching infinity as y approaches 0 coming from this way, because our function looks like this. So it wouldn't make any sense for it to be like it. That just wouldn't make any sense, because here we are approaching 0. So we'll have a point just somewhere about right here. We know it's going to be above the x-axis. Now if we go over to our 0 point here, is it going to go this way or this way? Well, if we look at the way our graph is going to be sketched, we see that we're going up here, and it wouldn't make any sense if we went up here. So we know here we're below the x-axis. So we're going to hit 2, negative 2, somewhere down here. I don't know exactly where we're at, but let's just say it's right there. And then we know we're going to cross at 0, 0 because of what we were given here. So we know we have a point, so we know that we're going to cross there, so we're going to use this, and we're going to sketch it like that, because that's our curve. And we're going to land somewhere above the x-axis on 1. Now with this point, we know that this is going to continue on because the function doesn't have any limits. So we know that it's going to be negative infinity on the x-axis this way. So we know we're going to curve up, and we're going to keep going this way. At this point, we know we have our asymptote, and we have this shape. So we know that we're going to come down like this. At this point, we also know we have an asymptote on 6 on the right side, so we're going to curve up like this. But we don't know yet if we're going to be above or below this 9. So let's look at this point. And this point tells us we have this shape, which is like this. So it would only be reasonable for us to go this way. It wouldn't make any sense for us to be all the way down here with this shape. It could, but it's highly unlikely. And then lastly, we know we have this shape. So we're going to take this and we're going to connect it to this dot here with this shape, concave down. And that's our graph.